welcome to the edge of human engineering. Tonight on Dark Sky Dive, we witness the birth of a true Martian explorer. Mars is a desolate and unforgiving graveyard, where the atmosphere is thin and the nights freeze everything into absolute silence. Temperatures here can plummet to minus 100 degrees Celsius, a brutal cold that can shatter ordinary metal like glass. Deadly cosmic radiation sweeps across the surface every single day, destroying any organic material that dares to exist in the open. Yet, into this hostile hellscape, humanity has chosen to send the most sophisticated machines ever built by our hands and minds. These are the Mars Rovers, our robotic avatars that roll across the red dust, searching for secrets of the ancient past. But long before they ever touch the alien soil, every rover begins its life in absolute silence back on Earth. Deep inside these high-tech facilities, a miraculous process of science and nutrition for the machine's soul is about to begin. A Mars robot is not simply assembled like a consumer product. It is born through a slow, painful, and precise process. There are no mass production lines here. There is no speed. There is absolutely no room for trial and error. Each Mars rover is a unique individual, handcrafted in a clean room under the direct supervision of the world's best engineers. A single tiny mistake here is not a warranty issue. It is the permanent death of a billion-dollar mission. This is the clean room, a sanctuary where ordinary dust is considered more dangerous than a critical software error or bug. The air inside is filtered continuously. Even dust particles smaller than a human hair are aggressively hunted down and removed immediately. Engineers must wear full body suits because human skin cells and hair are contaminants that could ruin delicate scientific instruments. The reason is simple. A single dust particle in the wrong place could jam a mechanism millions of kilometers away. There is no chance to wipe it clean. There are no repair technicians waiting on Mars to fix our mistakes. Everything must work perfectly from the very first moment. This creates an atmosphere of extreme pressure and absolute precision engineering. The frame of a Mars rover is not just to hold the shape. It is a skeleton designed for survival. It must withstand the violent vibrations of a rocket launch and the crushing acceleration that is many times Earth's gravity. And then, it must survive the freezing nights on Mars, where extreme cold attacks the integrity of the metal structure. Special aluminum alloys and titanium are used at stress points, often utilizing a honeycomb structure to maximize strength while minimizing weight. Every joint is calculated so it does not become brittle in the cold or deform when the sun rises high. On Mars, temperature does not change gradually. It swings wildly in minutes, causing materials to expand and contract constantly. In a Mars rover, a screw is never just a fastener. It is a critical component that holds the mission together. It acts as a load-bearing point and a vibration transmitter, making it a potential fatal weak point if it fails. Each screw must not become brittle at minus 100 degrees, nor can it loosen during the violent shaking of launch. They are designed to resist the intrusion of Martian dust, which could jam the threads and destroy the structural integrity. These components undergo thousands of vibration cycles and sudden heating tests to ensure they will hold tight forever. If a single screw fails during testing, the entire design must be reconsidered. There is no room for compromise here. Mars does not have paved roads. Its surface is a treacherous mix of sharp rocks, fine sand, and electrically charged dust. The rover wheels must not tear, jam, or wear down too quickly, despite the abrasive nature of the alien terrain. Each wheel is reinforced and designed with a special pattern that provides traction while also allowing it to self-clean. If just one wheel breaks or gets stuck, the rover could be trapped forever, ending the mission in a tragic standstill. The robotic arm is where the real science happens. It is a mobile laboratory capable of reaching out to touch Mars. It must drill into rock, collect samples, and deliver them to the analysis chamber, all while battling the freezing cold. The moving joints are lubricated with special materials that do not freeze solid or evaporate into the thin Martian atmosphere. A stuck joint means the robot loses its ability to research, turning a scientific marvel into a very expensive remote-controlled car. The rover has no real-time connection with Earth. Signals can take from 4 to over 20 minutes to travel one way. This means the robot must decide for itself. It must avoid obstacles and protect itself without waiting for human commands. The computer on board is not powerful or fast by modern standards, but it is incredibly stable and resistant to crashes. They are designed to withstand radiation, avoid memory errors, and run for years without needing a single hard reset. Before leaving Earth, the robot is tortured without mercy. It is placed in vacuum chambers and frozen for many days. It endures violent shaking and runs continuously in the dark. NASA does not simply ask if the robot will work. They ask, when will it break and how will it break? They must understand failure completely before flight is authorized. Only when they fully understand every potential failure do they allow the robot to be strapped to a rocket and fly. Once the robot lands successfully on Mars, everything becomes quiet. The noise of the launch and the testing is gone. There are no engineers standing by. There are no factories. There are no spare tools. It is completely on its own. All that remains is a machine, a strange planet, and the command sent from millions of miles away on Earth. Every single day the robot continues to operate is a massive victory for engineering and a triumph of human persistence. Why do we accept this harshness? Because these robots are our first eyes on a world that is not our own. They go before us, taking risks so we don't have to, opening the path for the future footsteps of humanity. And it all begins with a single small screw, designed with passion to survive at minus 100 degrees Celsius. This robotic face looks out at the horizon, capturing images that will change our understanding of the universe forever. Inside the rover, miles of cabling must be routed perfectly. A pinched wire could mean the loss of a vital instrument. These cables are the nervous system, carrying commands and power to every extremity of this complex mechanical explorer. It can shoot lasers to vaporize rock, analyzing the chemical smoke to detect signs of water or ancient microbial life. Data flows back to Earth, turning into graphs and colors that tell scientists the history of a planet billions of years old. We see echoes of our own home in these rocks. Ancient riverbeds and dry lakes suggest Mars was once like Earth. But Mars is volatile. Global dust storms can block the sun for weeks, starving solar-powered rovers of their vital energy. Modern rovers carry nuclear batteries, allowing them to work through the darkest storms and the coldest winters without sleeping. This nuclear heart generates heat and electricity, keeping the electronics warm when the environment tries to freeze them to death. Getting to the surface requires a parachute capable of withstanding supersonic speeds, deployed at the precise microsecond to prevent a crash. The fabric is tested in giant wind tunnels to ensure it won't shred apart when it hits the thin Martian atmosphere. The landing sequence is often called the 7 minutes of terror, a complex ballet of rockets and cables controlled entirely by computers. Back on Earth, the team can only wait. By the time they hear the signal, the rover is already alive or dead. When that signal arrives, it validates years of sleepless nights, missed birthdays, and the relentless pursuit of engineering perfection. The rover wakes up and opens its eyes. It sends back the first high-definition images of a world no one has touched. These images are not just data. They are portraits of a neighbor planet, inviting us to come and explore closer. The mission is to find evidence of past life. The rover looks for chemical signatures hidden deep inside the ancient rocks. It collects samples and seals them in tubes, leaving them on the surface for a future mission to bring back home. This is the first step of a relay race. This robot does the hard work so that we can one day touch Mars. But before that future arrives, the work continues here on Earth. Every lens must be spotless, every sensor calibrated perfectly. The complexity is staggering. There are thousands of connections, and a single loose wire could silence the rover forever. They blast the robot with noise loud enough to kill a human, ensuring the sensitive electronics won't vibrate apart during launch. It is a brutal process, but necessary. The ride to space is violent, and the robot must arrive in perfect condition. Inspections are rigorous. They check for cracks, loose screws, or any sign that the machine is not ready for the journey. Thermal blankets are applied to keep the internal heat in and the cold out. It wears a coat of gold and mylar. Surprisingly, these high-tech blankets are often sewn by hand, requiring the steady touch of a skilled craftsman to fit perfectly. When the robot is finally complete, it stands as a monument to what humans can achieve when we work together. It must be folded up like complex origami to fit inside the tight confines of the spacecraft that will carry it. Once sealed inside the aeroshell, no human eyes will ever see it again. It is ready to leave our world. The journey to the launch pad is the final parade on Earth. The engineers say their silent goodbyes to their creation. As the sun rises, the rocket stands ready. It holds the hopes of thousands of scientists and the curiosity of billions. The countdown reaches 0. Controlled explosions push the machine away from the gravity of Earth, aiming for a moving target. It punches through the atmosphere, entering the silent vacuum where it will cruise for months before reaching its destination. The cruise is long and quiet. The robot sleeps, while the navigation team on Earth carefully guides it through the dark. As Mars approaches, the spacecraft wakes up. Systems come online. The heat shield prepares to face the fire of entry. It hits the atmosphere at hypersonic speed. The heat shield glows like a sun, protecting the delicate rover inside from burning. The parachute must deploy perfectly. There is no second chance. It is a moment of pure physics and engineering faith. The radar scans the ground. The computer makes split-second decisions, steering away from cliffs and craters to find safety. Rockets fire to hover. The rover is lowered gently on cables, its wheels reaching out to touch the alien soil. Once down, the cables are cut. The delivery system flies away to crash, leaving the rover alone in the silence. It runs a health check. Every system reports green. The mission has officially begun. The Explorer has arrived at its new home. Over the coming years, it will travel miles, climb hills, and descend into craters, driven by the curiosity of its creators. It leaves tracks that will last for centuries, marking the presence of humanity on a world we have yet to visit. At night, it watches the stars. It might even see Earth, a bright morning star, waving from across the solar system. Even as it ages and parts begin to fail, it continues. It pushes past its design limits, driven by stubborn code. The dust accumulates. The joints get stiff. But as long as it has power, it will answer the call from Earth. The knowledge it sends back rewrites our textbooks. It tells us about the water that once flowed and the climate shifts. Generations of scientists may work on a single rover. It becomes a legacy, passed down from mentor to student over decades. One day, a human will stand beside it. They will brush off the dust and read the plaque on its side. They will recognize it not just as a machine, but as the brave pioneer that scouted the path for their arrival. Like the wooden ships of old, these rovers sail the cosmic ocean. They are the vessels of our modern age of discovery. The search for life drives us. Are we alone? The answer might be hiding in the dust, inside the rover's sample chamber. Complex instruments perform chemistry experiments that would be difficult in a lab on Earth, all inside a box on Mars. The landscape is vast and beautiful in its desolation. It is a world waiting to be understood, waiting to be awakened. The sunsets are blue, and the sky is pink. It is a familiar yet wrong world, a twisted reflection of our Earth. Climbing mountains on Mars takes months, but the rover is patient. It does not know boredom, only the mission parameters. Behind every movement is a debate on Earth. Scientists argue over which rock is most important, maximizing the rover's limited time. It peers into deep canyons where water may have flowed billions of years ago. It stands on the edge of history, It endures the seasons. The winters are long and dark. The summers are dusty. Yet, the machine persists without complaint. It carries the flag of its nation, but it represents the curiosity of our entire species to know what lies beyond. We are two worlds, separated by millions of miles, but connected by a stream of radio waves and human ingenuity. As long as its wheels can turn and its batteries hold charge, it will keep exploring, keep questioning, and keep discovering. From the clean room to the red desert, we have seen the incredible life cycle of a machine built for the impossible. It is a reminder that when we focus our minds and hands, we can overcome any distance and survive any environment. The Mars Rover is more than metal and code. It is the embodiment of our refusal to stay bound to Earth. It teaches us that exploration is difficult, dangerous, and expensive, but it is the only way to truly understand our place. Thank you for joining this journey to the Red Planet. For more deep dives into the universe, subscribe to Dark Sky Dive.